Hey everyone, welcome back to my channel. A single-stage pressure regulator reduces a high inlet pressure to a lower, more stable outlet pressure. It achieves this through a simple valve mechanism controlled by a diaphragm and spring. As gas enters the regulator, it applies force to the diaphragm. This force is opposed by the spring, which is adjusted to a specific tension to maintain the desired outlet pressure. When the outlet pressure drops, the spring pushes the diaphragm down, opening the valve and allowing more gas to flow. Conversely, if the outlet pressure rises, the diaphragm is pushed up, closing the valve and restricting gas flow. This self-regulating mechanism allows the regulator to maintain a relatively constant outlet pressure despite fluctuations in the inlet pressure, such as when gas is being consumed from a cylinder. However, single-stage regulators are susceptible to a slight increase in outlet pressure when the inlet pressure drops significantly, as the forces acting on the valve change. The working principle of a single-stage pressure regulator involves a diaphragm and spring mechanism that adjusts a valve to maintain a stable outlet pressure despite fluctuations in the inlet pressure. This self-regulating system ensures a consistent delivery pressure as gas is consumed from a cylinder. However, single-stage regulators may experience a slight increase in outlet pressure when the inlet pressure drops significantly due to changes in the forces acting on the valve. Comparison to two-stage regulators. Single-stage regulators have a less controllable delivery pressure compared to two-stage regulators. Single-stage regulators show little change in delivery pressure with flow rate, but have a relatively large supply pressure effect, variation in delivery pressure as inlet pressure drops. Two-stage regulators have a considerable but only small supply pressure effects, providing more constant delivery pressure. Single-stage regulators are recommended where inlet pressure does not vary greatly or where periodic readjustment is acceptable, while two-stage regulators provide more stable delivery pressure without needing readjustment. Potential issues with single-stage regulators. When the inlet pressure drops significantly as gas is consumed from a cylinder, the single-stage regulator may experience a slight increase in outlet pressure due to changes in the forces acting on the valve. Particles in the system can impact and damage the non-metal valve seat material, causing the outlet pressure to increase without changing the regulator adjustment. Sudden drops in outlet pressure when the regulator opens or fluid is flowing can indicate a clogged inlet. Installation and maintenance. Manufacturers recommend installing a filter upstream of the regulator to prevent contamination. Regulated gases should be free of oils, greases, and excessive moisture to avoid fouling or damaging the regulator components. Oxygen applications require specialized knowledge, compatible lubricants, and extra cleaning to remove petroleum-based contaminants. Regulators should not be connected to a supply source exceeding the rated inlet pressure, and should not be used as shut-off devices. Thank you for watching and don't forget to like, share, and subscribe until next time.